Hi everyone, welcome back. We are working on IM1 Skill 4. So today we're going to write math expressions from words or tables. So that means we're almost like translating. So we're going to read something that's written in English and we're going to translate it to math. So a few vocabulary that we need to go over so that when you see these phrases, you know how to translate them. Okay, so the first one that we have, and let me zoom in just a little bit, is initial. We might see this in word problems a lot, but when we see this word, we should think of some math operations. So the first thing is initial tells me that this is to start with. So to start with. We could think of it as the beginning. And mathematically, this is a constant number. So constant number. That means it doesn't change. So we're not going to add it to something until we have every other piece of our expression. It's just a number, and it's going to look like just a number in our equation or expression. So it's a constant number. Okay, the next one is division. So here are some phrases or words that if we see them, our brain should tell us we are working with division. So the first one is quotient. We hear this one a lot. Maybe divide. Obviously, that's a straightforward one. Separate. And then one that we'll see a lot on this is halves or thirds. So half or third. You could see quarter, maybe divide by 5, but halves and thirds is what we see most. All right, next one is addition. So we'll see this a lot in these expressions. Addition. Okay, so we might see more than, maybe total, sum, and we've got a lot for addition. There are more, but these are the ones we're going to see most often. Okay, moving on, we've got subtraction. So let's go over some of these phrases. Subtraction would be less than. Maybe you might see the word smaller, difference, and maybe even take away. Okay, so there's a lot for difference. The next one is equals. If we see these words or phrases, that tells us when we're writing our equation, that's where the equal sign goes. So for equals, it might be the word is, same as, and we'll just leave it like that. We're going to see mostly those two and like total for equals. Okay, and then last one for the operations is multiplication. Again, this one we're going to see a lot. And for this one, we might see the word twice, maybe 3 times. So the word times, per. So if you make $75 per hour, that means you are taking 75 and multiplying by the number of hours. So that's multiplication. And then we've got our tricky ones, which are switch phrases. So they mean the operations up above, so either like multiplication, subtraction, addition, but a switch phrase tells us that the order that it happens in the sentence is switched with the way that you write it in the expression, so it's almost like opposite. So let's go over what these might look like. The first one we're going to see a lot of, and this is the one I see most mistakes with, is less than. So you'll see that we already had this in the difference section for subtraction, but less than tells me that I'm actually going to switch the order that the numbers are in the sentence, and you'll see an example of that later. Okay, and next, or another one is if you see the phrase times the sum of. Okay, so when you see times the sum of, then after that you're going to switch the order, and again, you'll see examples of these. I just want to get them down. And then you might also see times the difference of. Okay, so I'm going to put a little star here, and I would do that on your paper as well. These ones are the ones to look out for. These are the tricky ones, okay? So let me change my color, and we can get started on translating. I've made this so that we go by operations, and I believe we're going to start with addition. So let's zoom in a little and get started on translating these. Okay, so I see n more than 9. All right, so if I were to look up at all my operations, oh, good, I found it, more than. That's in my addition section. So this is n plus 9. And it's as simple as that. We're just translating into a math expression. Okay, next one, 8 increased by a number. So if I have increased by, increase tells me more than, so that's adding. So 8 increased by a number. When you see a number, I'm going to put that in quotes, that's any variable. I picked X, but you could totally pick whatever you'd like. Okay, next one, we're still on addition. So X increased by 10. So we're getting more than what we started with, X plus 10. All right, and last one in this section, the sum of n and 6. Remember, sum tells me to add, so n plus 6, that's a sum. All right. Moving on, now we got a problem with difference. The difference of z and 7. So I'm going to take z and subtract 7. So notice this is not a switch phrase. I wrote the values in the order that they were in the sentence, so they stayed the same. I just put subtraction in between them. Okay, number 7, n less than 7. Okay, this is a switch phrase. This is a tricky one. So I have 17, and then I want to represent n less than that. So I'm going to write the 17 first, and I'm going to take away n. So now you'll see this is why it's called a switch phrase. N came first here, but it actually belongs after the 17 if you're using subtraction. All right, number 8, the difference of 13 and a number. So again, this is just 13 and then subtract a number. Let's use y this time. Why not? And then last one in this section, 18 decreased by 4. So we'll start with 18 and then subtract 4. If you wanted to simplify this, you could just write the number, but right now we're just practicing the mode of translating from here to here. All right, now we've got something that says twice a number, twice a number. So twice tells me I'm multiplying, and if you remember that word twice, that means 2 times a number. So I've got 2 times x, and we actually like to write that as just 2x. So I would prefer this expression right here, and that's actually just one term. Okay, 11, the product of 6 and y. So the product of 6 and y. Remember in math, if two things are next to each other like this and there's no symbol, that means multiplication. Okay, 12, 9 squared. Now we didn't have this in the vocabulary up above, but squared, that means that I'm going to multiply 9 by itself. So I can either write 9 times 9, or we can write 9 squared. So that's an exponent problem, but it really means multiplication because it's 9 times 9. Okay, very similar to this one, but this time we're taking 3 and we're cubing it. Remember, that means to multiply by itself 3 times. So this is 3 times 3 times 3. If you would like to write it with an exponent, that's 3 to the third. Okay, 2 more. Half a number. So I've got half, that means division, and a number, that means a variable. So I want 1/2 of a number. I did 1/2 times y. So actually what I did there was multiplication. If we want to make it look like division, we would take y and we would divide by 2. Those both mean the exact same thing. So 1/2 times a number is the exact same thing as a number divided by 2. All right, last one, the quotient of Q and 4. Quotient, that's our division word. So Q divided by 4. And notice I wrote them in the order that they were in the expression. Okay, so now that we've practiced writing some expressions, let's take it one step further and apply it to a table. So if you're following along on my note paper, you're going to need to jot this table down. So take a moment, pause the video, and jot this down. And then I'm going to move on and assume that you were able to pause that and copy down your table. All right, so now that you have it, we're going to answer some questions about that table. It says, using it, write an expression for someone who buys S number of bananas and T number of apples. So if someone buys these products, well, it's going to cost a certain amount. So if I buy S number of bananas, I've got to take the price of them and multiply it by how many I buy. So I'm going to start this with 0.42 S, and then I'm going to add, and then the price of apples is 56 cents, so I'm going to add 0.56 T. And I'm going to write those in black just to make sure we know those are variables. So this is S and this is T. So this expression represents buying S number of bananas. So we take the price times the number, and then we're going to add the price of apples times how many we buy. So that's it. That's the expression. This represents how much it would cost to buy some unknown number of bananas plus some unknown number of apples. All right, moving on. What does the expression 0.78H represent? So I'm going to look at my table and see, where do I see that value? Okay, cool. I see it right here. So that is related to cherries. This is the price of cherries. So if I have the expression 0.78H, that tells me that this expression represents the total price. So the total price of buying, my words got a little jumbled, H cherries. So we don't know what number that is, but we know that if we take the price of one and we multiply it by H cherries, whatever that number ends up being, it'll give us the total price of them. All right, last question for this table. Write an expression that represents the cost of buying 4 more apples than peaches. Okay, so again, we don't know how many of each we are buying. So I'm going to zoom out just a little, and I'm going to write next to my table some expressions for how many of each we're buying. Okay, let's start with apples. So it says 4 more apples than peaches. So apples is some amount that's 4 more than peaches. So I know I'm going to be adding 4. And then it just says then peaches. So I don't know how many peaches we're buying. So whenever we don't know what the value is, we're going to make that a variable. Peaches, we'll make this y. Okay, so if I want these expressions to be related to each other, y is how many peaches we're buying, and y plus 4 is how many apples we are. So see how this represents 4 more than peaches. All right, so we need to write an expression that represents the cost of buying these two amounts. So y plus 4 apples, we're going to multiply it by the cost. So 0.56 times how many we buy. And then we're going to add the cost of peaches times how many we buy. So this expression right here represents buying y plus 4 apples. So remember, you take the price and you times it by the amount. And then we added y amount of peaches. So remember, you take the price and multiply by the amount. This is something that looks a little more complicated than it is. You do this all the time when you go shopping, but just when we don't have actual context, it might just look a little more complicated than it is. All right, guys, thanks for watching, and I hope that you guys move on to skill number 5. I'll link it at the end of this video. Okay, bye-bye.